So here's the answer to the problem. We're going to confirm it's the answer and then show how we actually could calculate these rates. So these are one-year spot rates that have the properties we need, and this is with a risk-neutral probability of a half. We're going to assume that the probability of an up and a down state are both a half, and if we wanted it to be different, we would get different rates. But with this risk-neutral probability, this lattice, using the procedure we developed in the prior module, will price our zero coupon bonds correctly, and number two, Dave, I just burped, so I hope you don't pick that up. And number two, we're going to see that it provides the volatility of the forward zeros that are also desired from that earlier table. So let's do that, confirm that this actually works. The first thing we're going to do is we can, well, there's a point made on the slide here that this tree may appear to behave differently than a stock price tree. And again, the notion is there's nothing about the evolution of interest rates on this tree that there's nothing about this evolution of interest rates that reflects some perspective of the analyst in terms of how interest rates in the future will behave. You can think of this as these are interest rates which, under a risk-neutral probability, which we know is not a real-world probability anyway, under a risk-neutral probability prices today's zero-coupon bonds. These interest rates do not have to look realistic. They don't have to behave realistically, because we know they're interest rates that are being used with an artificial kind of probability structure or risk-neutral structure. So when we develop such a lattice, the interest rates may look unusual to us, but we have to remember that they do not reflect a bias or an opinion of the user as to how interest rates will behave in the future. They simply reflect an appropriate collection of interest rates which will price our zeros and reflect the yield volatility we desire. So what we want to do now is verify that the data in that table actually is correct. And what does that mean? So we need to verify that the tree matches the yield curve. So we'll have to price the 1, 2, 3, and 4 year zeros and check that the yields are the yields on that table. To check the yield volatilities, what we need to do is take a look at the 2, 3, and 4 year zeros and evaluate what their values will be in 1 year time, and calculate the volatility of the implied yield on those forward zeros, and make sure those match the table. So, first of all, we can, by using a simple formula, these are 1 year interest rates, otherwise we'd need a multiplicative factor of h somewhere. These are 1 year rates. These are the prices of 1 year zeros. So 0.8331 is the price of a 1 year zero. So this goes from, this is time 0, time 1, time 2, time 3. This is the price of a zero at time 3, a 1 year zero at time 3 in the uppermost state. And if we go back to that interest rate, it was 20% or so, 18%, we would confirm this price. So this is the collection of 1 year zero prices. And we're going to use these to price the zeros at time 0. Remember, from the prior module, we can price zeros at time 0 using future interest rates or future 1 period zero coupon bond prices.